Good morning. Thank you all so much for coming. How do people find the first day of the event? Good, good, good. Okay, this is the first year we've done this. How many people are coming back next year? Good, all right. Some people are waiting to see how the second day goes. I had a great time yesterday. The favorite part of my job is hearing stories from you all about how you're using data science to thrive. And yesterday, I was blown away by the stories from Moody's Analytics, from JP Morgan, from Bristol Myers Squibb, concrete examples of how they're using data science to reduce risk, to make their business more competitive, or in the case of Bristol Myers, literally helping to cure cancer. What I like about these stories is they make vivid and concrete the potential impact that data science can have on business, but also really society more broadly. At the same time, I think there are some real obstacles that we're facing to realize that full potential. And to give you a sense of what I mean, for every one of the stories like the ones yesterday that we hear 10 quotes like these. It takes 6 months to get a new package, so I secretly bring my personal laptop into work. We built our new headquarters in less time than it took to get a model into production. Knowledge management is so bad, every day is like my first day. And we've got dozens more like this. These are real quotes from data scientists we work with. This morning I want to talk about how I think we can break through these obstacles. There's a sort of a popular aphorism: if you want to see the future, look to the past. And in that vein, I want to start by just telling a quick story about another time in recent history when there was a set of innovative new capabilities, and yet technical, creative, inventive people felt stuck. So I want to talk about the history of software development, because I think it offers an insight into the nature of these obstacles we're looking at in data science. Most people know that in the 70s and 80s, companies developed software using a methodology or a set of methodologies and approaches that we called waterfall. In the 1990s, a new methodology emerged that later got branded as agile. Now today, basically everyone uses this agile methodology, and people look at waterfall with disdain. What a lot of people don't think about is why software teams used waterfall in the first place. And if you dig into it, what you'll find is that waterfall had worked for decades to build and deliver great hardware products. Waterfall fueled what I consider the first era of computing. It was the hardware era. And so when software teams started developing software projects at scale, more companies began developing software capabilities, they sort of course, tried the same approach. Now, what a lot of people don't think about is why those teams used waterfall in the first place. And like I said, it was sort of because it had worked for a long time to fuel this first era of computing. So when software teams started trying this waterfall approach for bigger projects, more projects, they got stuck. It didn't work. And so projects didn't ship on time or were delayed. The final products didn't live up to people's expectations, and the software engineers felt frustrated. Now, the Agile movement, at some fundamental level, reflected a deep recognition that software was fundamentally different from hardware. The software was a phase change. It was a new era of computing. And software is different from hardware because the materials used to make it are different, and because the nature of experimentation and research during the development process is different, and because the way that software changes and evolves after it's been built is different. This may all seem very obvious in retrospect. Of course, software and hardware are different. Why would we expect that the approaches used to make one would work for the other? Once people realized this, it unlocked software's potential. It sparked this revolution, and software started having a bigger impact across business and all different parts of society. So today, I think we are in the very early days of the next era of computing. That's what I think data science is. And I think that it is as different from software as software was from hardware. And if we want to unlock its potential, we have to recognize that difference and treat it accordingly. To do that, I want to start with a question, which is, what do data scientists make? Hardware engineers make chips and drives and boards. Software engineers make applications and services. So what do data scientists make? Well, beyond the hype about machine learning and artificial intelligence, At the heart of data science, the source of its power, the source of its impact, is something called a model. You guys know all this already, but what I mean by a model is a special type of algorithm. It's an algorithm whose instructions are induced from a set of data and then are used to make predictions or recommendations or more generally to prescribe some action based on a probabilistic assessment. A lot of talk about data science focuses on the first word, data. We talk about big data, we talk about being data-driven. There's this popular metaphor that data is like the new oil. These are oil canisters, but they even sort of look like database silos. The issue with that metaphor is that data is static, or sorry, oil is static. It just sits there. It doesn't do anything. And so if data is like oil, then models are like engines. They make things happen. They initiate action. And for better or worse, they can increasingly do so autonomously with a level of speed and sophistication that people can't usually match. That makes models a new type of digital life. They're not software, they're not data, they're not BI dashboards. They're not like anything we've seen in most business contexts before. So data scientists make models. And this isn't merely a technical or a semantic distinction. Once we started viewing the world through this lens of models as the principal output of data science work, we noticed something pretty incredible. If you look at the most successful companies in the world today, you'll find models at the heart of their business driving that success. An example that most people are familiar with is Netflix. So Netflix has driven incredible subscriber engagement and retention with its famous recommender model. This is so valuable to Netflix that in 2006, it offered a $1 million prize to anyone who can improve its algorithm. And that turned out to be a bargain. Last year, Netflix said that this recommender model was worth over $1 billion a year to their business. And actually, more recently, it's come out, Netflix is now using models to generate content programming ideas. And last week, I think Netflix surpassed Disney's market cap. Perhaps a lesser-known example outside the tech world, Coca-Cola uses a model called the Black Book to help it manufacture orange juice efficiently. It has data on 600 constituent parts of flavor profiles and consumer preferences, things like acidity and sweetness and pulp. And it uses data on weather predictions, crop yield estimates, real-time pricing information to dynamically adjust a recipe for manufacturing orange juice that maximizes consumer satisfaction and profitability. Insurance companies have long used models to predict how risky someone is to insure. And now they're finding new parts of their business they can run on models. For example, if you're in a car accident, you can now take a picture of your accident on your phone, send that picture in, and get a real-time damage estimate from a model instead of having a claims adjuster come inspect your accident. So that improves customer experience and also saves insurance companies cost. These are examples of model-driven businesses, and they use models to create competitive advantage in two ways. The first, models are often the foundation for breakthrough products, killer features, or even whole new revenue streams. I think about autopilot in cars as a great example of this. Second, it's often much more concealed, but even more powerful. Models allow companies to create operational efficiency that compounds through constant incremental improvement. This is that upper bar in what Nate was talking about, past the sort of 80% mark. I think the best characterization of these two dynamics of models I've ever seen was actually in the 2016 letter to Amazon shareholders that Jeff Bezos wrote. Here's what he wrote. At Amazon, we've been engaged in the practical application of machine learning for many years now. Some of this work is highly visible. Our autonomous primary delivery drones, the Amazon Go convenience store that uses machine vision to eliminate checkout lines, and Alexa, our cloud-based AI assistant. But much of what we do with machine learning happens beneath the surface. Machine learning drives our algorithms for demand forecasting, product search ranking, product and deal recommendations, merchandising placements, fraud detection, translations, and much more. So these dynamics of models, on the one hand, the ability to create this unbounded upside in revenue growth, and on the other side, the ability to create this operational efficiency that compounds to create cost savings or other benefits, those make models the new super weapon of competitive advantage. And that means that if you're not a model-driven business, you're facing an existential threat. Your competitors are going to keep incrementally improving and taking more and more sort of share of the spoils. And we're already starting to see this play out. There's recent research that's shown that 20% of companies, only 20% of companies, are making extensive use of models, but those who are have profit margins that are about 10% higher than those who aren't. So that's billions of dollars in difference today, and the gap is only going to get wider. And these 80% of companies, it's not like they aren't trying. They're hiring data scientists, they're spending money on tools and technology, and they're getting mired in this morass of problems that I mentioned earlier, in areas ranging from technology to collaboration to business process change, culture change, to politics and stakeholder management internally. When we talk to data scientists, we get the same sense, the same feeling of being sort of stuck and frustrated that those early software engineers described when they were working in a way that was designed for a previous era. We've worked with hundreds of companies now that are going on this journey, and the pattern that we've noticed is that companies get stuck when they try to treat models using the same approaches they use for a sort of a past era of assets, when they try to treat models using approaches they use for software or for data. We call this the model myth. It's the misconception that because models involve code and involve data, you can treat them, you can manage them the same way that you would manage software or manage data. And this doesn't work because models are different in three important ways. The materials used to make models are different. Models involve a lot more data than software projects do, and they also involve much more computationally intensive algorithms. So you need things like scalable compute, you need things like specialized hardware like GPUs, and at the same time, models leverage packages from a vibrant open source ecosystem that's innovating every day. We heard Wes talk about this yesterday. So data scientists need extremely agile technology infrastructure to drive rapid research. Second, the process used to make models is different. Models, or data science it's research. It is emergent, it's iterative, it's exploratory. You might try hundreds of ideas before finding one that works. And that means that data scientists need new kinds of tools to facilitate exploration and facilitate experimentation so they can drive breakthroughs. And finally, models' behavior is different. Again, just look at Nate's graphs of or charts of the hurricane predictions and everything. Models are probabilistic. They have no correct answer. They just have better or worse answers once they're live in the real world. And unlike software, I mean, software, there's no notion of retraining software. But in the case of a model's performance can change as the world around it changes, as the assumptions that you baked into it evolve or become less valid. So that means that organizations need new capabilities for reviewing, quality controlling, and monitoring models. Many of you are probably bumping into the model myth every day. Here are some examples of stories we've heard from folks we work with. The model myth is when you need the latest version of a Python package to finish your research project, but in order to get that, IT makes you put that change request through a 3-month change management governance process, and so your research is stuck. Or the model myth is when you need to update a chart that was in a presentation you had a few months ago, but to go do that, you can't because you can't find the data that you used or the parameters you used for your experiments because those aren't tracked anywhere in GitHub or in your wiki. Or the model myth is when you are struggling to explain to an executive that 80% of your data science team's projects are going to fail, and that's actually completely fine because data science is research. Or the final example of the model myth is when you have built a great model, but it takes 9 months to get it into production because someone has to recode it, re-implement it in Java so it works in the production systems you have. And no one has connected the dots to realize that that extra friction point will make it impossible to retrain the model at a responsible frequency. What are we supposed to do to break through the model myth and accelerate this process to becoming model-driven? Well, over the last 4 or 5 years, we have been, at Domino, sort of feeling out the edges of this problem. And along the way, we've described different parts of it. At various points in time, these are actual taglines from landing pages for our company over the last 5 years. At various points along the way, we've talked about the need for more agile technology infrastructure for data scientists. We've talked about new kinds of tools and workflows to accelerate experimentation. We've talked about the need for new ways to easily deploy models. And we've talked about how models require different kinds of knowledge management to facilitate collaboration and reproducibility. And at every step along the way, We felt like there was something bigger that we were trying to say, something that was just on the tip of our tongue. We were sort of feeling different trees in the forest. So about a year ago, we took a step back, and today I'm really excited to show you how we put the pieces together. I hope you're going to find it helpful. Our basic view is that models are fundamentally different from software and from data and other business assets that have come before it. And what that means is that models require a new organizational capability to manage them. We're calling that capability model management. Now, in the past, model management has been a technical term of art. It's sort of referred narrowly to monitoring and tracking models that are running in production. We mean it as something much, much bigger. We mean it as a new category of technologies and processes that allow companies to consistently and safely build, validate, deliver, and monitor models that create competitive advantage. Model management has 5 parts to it. Model development is how data scientists build innovative models, experiment, and drive breakthrough research. Model production is how data scientists' work gets operationalized, how something goes from being a cool project to a real product integrated into business processes and affecting live decisions. Model technology encompasses the compute needs and the software tooling needs that allow data scientists to create and deliver and operationalize innovative models. Model governance is how an organization keeps its finger on the pulse of data science work, how it keeps track of the projects that are in flight, the models that are in production, and all the implications of the technology supporting those. And at the heart of this is something that we call model context. Model context is often overlooked. It is the set of artifacts, knowledge, and insights that an organization generates and accumulates as models are built and used. And this is often a company's most valuable intellectual property. So the ability to find it, reuse it, build upon it is critical to driving innovative research and competitive advantage. These are the 5 parts of model management, and when you have a capability that integrates them together, that is what unleashes the full potential of data science, and that's what allows a company to become model-driven. I want to stress it's not enough to hire data scientists. It's not enough to collect data. It's not enough to buy a single piece of technology or some new tool. Becoming a model-driven business requires changes across people, process, and technology. And what we want to do with this framework, and the reason I hope you'll find it helpful, is not that it's a single button solution or an easy fix, but that it gives you a framework to have a conversation internally inside your organizations to help communicate and align people about why models are different and what sorts of capabilities you need. All that being said, we at Domino, of course, are a technology company, a software company, and so we believe deeply in the power of great platforms and great products to help companies go on this journey and adopt these capabilities. You all work for organizations that clearly are investing in data science, presumably to get some transformative impact from it. And I know that because of that drives a kind of a sense of urgency and can result in almost a nose to the ground, getting caught up in the day-to-day tasks of a data science job. You explore data, you make visualizations, you hire other data scientists, you do projects, and all that stuff's important. But I think we're at a pretty unique moment in time with a pretty special opportunity to have an even bigger impact. And if you look at those early advocates of agile software development, by changing mindsets about what software is and how it was different from what came before it, they altered the course of their craft for decades. And I think we need to do something very similar. Because the real reason that your companies hired you, whether they even realize it or not, is to find someone to help them navigate this journey to become a model-driven business. And so if you can help them break the model myth, if you can help them change mindsets about models, help them realize how models are so different from what's come before them, then you will help data scientists everywhere feel unstuck. You will help unleash that full potential of data science, and you'll help your organizations become the next model-driven juggernaut. Thank you so much. We have a short break, and I hope you enjoy the rest of the conference today.